Today we'll be discussing what we see are industry trends for PV systems, commercial PV systems. These insights come from speaking with all of our network of dealers, our installers, and our suppliers, and we feel they're relevant for you as installers. Again, Hannah said, please submit any questions for the Q&A session in the chat bar, and we'll try to address as many as we can. So the topics today, so we're going to look at using 60-cell modules for commercial PV systems. Traditionally, 72-cell modules have been used, but we're also seeing an industry trend there. We're going to look at trends and developments in sizing the arrays in regards to the inverter capacity, looking at the optimal tilt of arrays on commercial projects and the benefit of choosing different tilts. We're going to look briefly at some NEC 2014 and the new NEC 2017 rapid shutdown considerations for rooftop commercial projects. We'll also look at some trends that we're seeing with the ballasted racking systems. We're going to specifically talk about the Aero Compact ballasted racking system that we can supply and their new metal roof racking systems for corrugated and standing seam metal roofs for commercial systems. I'll go through a brief example of maximizing the output of array on a commercial PV system using some different tilts. Also, we'll discuss the new Schletter carport Canopy solar racking that we can provide. Finally, we'll be discussing commercial ground racking solutions that we can offer, and if we have time, we'll go over some tax credit considerations and the value of presenting that to your customer as part of the system payback and cost analysis. So first of all, we talked about 60-cell modules. So 72-cell modules have been the industry standard for larger arrays. Thinking is that you can use less racking to meet your needs there. But we're seeing that the industry may be beginning to standardize more on the 60-cell format as we increase the watt classes there and as PV modules become more standardized and lower cost. And we see in a lot of cases, the 60-cell modules may be a lower cost per watt than the 72-cell equivalents. The 72-cell module formats, they're not readily as available, especially nowadays. Right now, there's a shortage of those 72-cell modules, so definitely consider using 60-cell modules in your projects. And we're seeing that the power densities on pretty much the same equivalent classes, either a 60-cell or 72-cell of the same brand, we're seeing the power densities are typically higher using the 60-cell modules. So case in point, REC with their Twin Peak technology, with their polycrystalline module, they're cutting the cells in half and have a unique chemistry there to get more watts out of polycrystalline modules. Their 60-cell equivalent modules at 290, we're getting a little over 16 watts per square foot there if you take the module watts divided by the area that the module takes up, whereas the REC 340 is only 15.74. So there is some hint there that maybe module manufacturers are using their better cells in their 60-cell formats and relegating some of the other cells to the 72-cell commercial modules. Some of the power watt classes that REC offers, the REC 290 Twin Peak 2 black frame white backsheet module. We are also currently offering the Hanwha Q-Cells QP 300 watt G4 module. And for locations where extremely high power densities are required, we do have some of the LG modules available for commercial projects. So also with the 72-cell modules, may not be able to use in some ballasted racking situations, as the ballasted racking, if it's frame mounted and it's grabbing the frames at the end, heavier snow loads may prevent you using those modules in some cases. Thicker frames are often used on the 72-cell modules, so they can be heavier per watt. And typically, you need 2 people required to move and handle the 72-cell modules. So your crew size may increase there, where you could possibly do with a smaller crew if you standardize on 60-cell modules. Typical watt class ranges that we see on 60-cell modules, polycrystalline, we see from 265 up to, like we said, the REC 290. Monocrystallines are readily available in the 275 to 300 watt class range, and the high efficiency watts, typical modules could be upwards of 350 watts on a 60-cell module. 72 cell modules in the polycrystalline, you can find them in upwards of 325 watts. With the REC, again, that's unique with their twin peak technology. So they can get higher wattage out of the same cells. And the monocrystalline modules, we've seen anywhere from 330 to 350 watts for standard typical cell modules. Some of the design trends that we're seeing when we're selecting inverters is the industry standard for years has been try to keep the DC to AC ratio under 120%. This is when modules were expensive in regards to the PV array, and you wanted to make sure that you got every kilowatt hour that the module was capable of producing, converting that to power that the homeowner or the industry was needing there. But as module prices are decreasing, the inverters have not necessarily decreased at the same trending rate. So having a higher DC to AC ratio, we're seeing 130% becoming very common. And some of the new inverters, such as the SMA 50 kW and the Outback Pro Harvest inverters, they have advertised DC to AC ratios of upwards of 150%. The inverters, as a result, will reach their peak output much earlier in the day. And you do allow clipping to occur during very high irradiance periods, but overall on that bell curve, you are gaining kilowatt hours at the site and not spending as much in the cost. These inverters are not damaged by the high PV DC to AC ratio. So a few inverters at the site, resulting in lower cost to source, install them, maintain them, fewer warranties to purchase, fewer inverters to go in service, and overall more kilowatt hours can be generated at the site with an overall balance of system and inverter costs. This is a lower cost per generated kilowatt hour for the system PV owner, and overall that's a big benefit there. Also, industry standard in the past has always been to try to get the tilts as close to latitude as possible. Again, when modules were very expensive, it was important to get every kilowatt hour out of them if it can. But with the higher tilts, that results in larger inter-row shading needed to prevent the modules shading each other. So right now, with the net metering, this may change in the future if net metering goes away or net metering is scaled back or less credit is awarded for net metered systems. But right now, the majority of systems are net metered, and your solar production does occur during the summer months when the sun angle is high. And lower tilt angles will allow much larger PV arrays to be installed in the location. And even though each individual module might be making 5% or 6% less, the module density just increases dramatically. Also, there are east-west racking solutions, and this almost completely eliminates inter-row shading, and it will maximize the energy density on the roof, and also allows your inverter DC to AC ratio to be pushed higher, as only half the modules are at optimal tilt in the morning. In the afternoon, you have the sun evenly distributed on east and west arrays, and in the afternoon, the sun is more suited to activating the west-facing modules. So again, that helps your inverter load, keeps that nice and consistent, good consistent output throughout the day with the east-west balanced racking system. So you can model this in different systems, computer software programs like PVSys, Aurora, Helioscope. Even PV Watts can help you determine your output and the cost and benefit of the different tilting of the arrays with the different tilt angles. So some rapid shutdown considerations. So NEC 2014, we all know about that. It's been in effect for a while. Most of the country now is on NEC 2014. Several states are now adopting NEC 2017. NEC 2014 defined the PV array boundary for 10 feet. And 2017 would reduce that PV array boundary to 1 foot. There is additional language in NEC 2017, but that does not take into effect until 2019 for inside the array, controlling the conductors and getting them down to a low voltage. This was pretty well covered by a different webinar, so I'm not going to spend a lot of time here. But anyway, three-phase string inverters, what we can do is we can mount them on racking or if there's a wall within 10 feet of the array for 2014, they would meet rapid shutdown if these inverters are placed up on the roof within that PV array boundary. And also there are racking systems from third party, or if you're using the SMA TriPower inverters, there's ballast racks that can locate the inverters within this PV array boundary and meet rapid shutdown. Separate remote trip disconnects can also be used to meet code. So Innovative Solutions does have a 1,000-volt rated universal rapid shutdown device that is inverter agnostic. It can be kind of expensive to employ, but it is there if needed, if there isn't a way to meet rapid shutdown in a different way. SMA, ABB, Fronius, Jinlong, they all have branded rapid shutdown solutions for 600-volt systems, but there's no current 1,000-volt solutions that they are offering. So for Fronius, for example, if we're doing a 208-volt system with their SIMO 10 or 12, those are 600-volt inverters. So we could potentially use the Fronius rapid shutdown solutions and boxes for those inverters, but we could not use it for the Fronius 15K 208 because that is a 1,000-volt rated inverter. Likewise, if you were using SMA inverters or single-phase inverters, using 3 of them to hit 208-volt Y connection or a 240-volt delta connection, you could use the SMA rapid shutdown solution in that case, as those are also 600-volt rated inverters. We are seeing a lot of interest in using inverters that meet the code without having to add any remote boxes or other considerations. So right now, we've had the Outback Pro Harvest inverters for a while now. They mount under the panels, under the arrays, right within the boundary, so they meet NEC 2014 and current NEC 2017 code. The new SMA Core 150 kW inverter, we'll talk about that a little bit later. They're easily located next to the array without any additional racking systems. And the SolarEdge commercial optimizers, since they deactivate the panels when a rapid shutdown is enabled, they inherently meet NEC 2017 and 2014 codes. Here is a map, and this is available online, that shows the states that are currently and what the adoption cycle is as of 7/12/2017. So 7 states right now are adopting and have adopted the NEC 2017 code. Sorry, 8 states. 2014 code is in effect in 29 states, and the 2011 NEC code is still in effect in 5 states. The other states are either in 2008 code or there's no universal statewide NEC adoption for those states. So briefly, let's talk about some different inverter options that meet rapid shutdown. The Outback Pro Harvest True String commercial inverters, they're available in both 480 3-phase Y and 208 3-phase Y configurations. The 480-volt inverter is an 8 kW inverter, can handle about 10,000 watts DC, 8,000 watts output. This is a direct 480-volt Y output, which is great. So no transformers are needed to get the correct voltage and interconnection if you're connecting to a 480-volt Y. And likewise, the 208-volt configuration inverter, same footprint, same size, but that's a 5.75 kW output inverter. Typically, you'll see about 7,500 watts DC power being put into those. They're very lightweight. One person can easily carry it up on the roof. It only weighs 24 pounds. There are individual ballast feet that can be employed on the inverter on the mounting holes, and it can be located right under the array on its own ballast feet, or it can be attached to a rail, or a different mounting method that is approved could be employed as well. There's integrated MC4 connectors on the 2 DC inputs. You can see them there in the photo. So this speeds installation time. You do need to make sure that we double the number of home runs as typically needed for these strings, so make sure that occurs. And they are MC4 connectors if you want to make sure that the connectors are matched for these inverters. There is very sensitive arc fault detection for each individual DC string. Outback has white papers that discuss exactly the advantages of their arc fault detection. They have much fewer false trips, and since it is individual string level arc fault detection, and tracking problems is very easy with these inverters. We can tell exactly which string is having the problem and go trace that. Since you don't have 5 or 6 strings coming to a combiner first, it definitely speeds any troubleshooting that might occur. We mentioned that these are mounted on the array. It's a NEMA 6 waterproof, robust enclosure, very, very durable. And we mentioned it's inherently compliant with both NEC and current NEC 2017 rapid shutdown requirements. Also of note here is that the output of these are a cable whip, and this whip would go into typically one of their AC splice boxes. And you can see there an example of that. So the 3 whips coming in, the splice box terminals would link up to 3 of the inverters. In the case of the 480 volt inverter, it would then travel and land on a 3-pole 40 amp breaker. And in the 208 volt, it would land on a 60 amp breaker. But these boxes as well can be placed under the array very conveniently. Speeds installation times and all the wiring from here is AC conduit and wiring from here back to the PV combining panel and ultimately to the interconnection breaker. So we've had a lot of interest in the new SMA TriPower Core 1 inverter. It's about the size of a dorm fridge if you get that size comparison, but very robust design. It's got a bottom fan that sucks the air up and pushes the air out of the middle, keeping it very cool in the location. So it's designed to be up on the roof, mounted there, or outdoors. So it does have 6 MPPT circuits. And what SMA did was they had 2 Amphenol H4 connector inputs for each of the 6 circuits. So it allows a total of 12 strings to be integrated here. Of note is since we have 2 or fewer strings for each MPPT circuit, there is no PV fusing required. So no combiner, no PV fusing is needed. Direct plug-in with the Amphenol H4 connectors. So definitely if you have modules with MC4 connectors on there, that's easily rectified. If you have both an MC4 crimper and H4 crimper with the pins, you can make your own home runs. MC4 connectors on the modules, run them to the inverter and put an H4 connector on the other side. So very easy to install these, very easy to lift up these inverters and place them directly on the roof or a concrete pad. There's lifting handles that are provided, so 2 people could move this guy around. And also it has integrated AC and DC disconnect for those jurisdictions that are requiring that. So one switch, one handle will both disable the AC and the DC at the same time. It has built-in Wi-Fi access for configuration, integrated data logger inside the inverter, all ready to go, and therefore access to the Sunny portal for monitoring is easily enabled. So as you can see in the stock pictures anyway, very easily suitable for lifting up and placing up on the roof for a roof mount operation. A small concrete pad could hold one for a ground mount operation. And carports, you would have a small bracket assembly that would meet the weight requirements of the inverter. So these are also very easily used for large carports. Still have available for the TriPower inverters for smaller arrays. There's a 30 kW, a 20 kW, 24, 15. I forget if there's smaller ones, but the SMA Ready Rack could be shipped with an SMA TriPower inverter and the CU1000 disconnect. So all 3 of those have to be ordered at the same time, and it's factory assembled as a unit, folded up on the cart, shipped in a pallet to the job site. A crane would then lift it up to the roof, replace it up on the roof, and then it would be located within the perimeter of the array to meet rapid shutdown. For commercial rooftop racking, we do have the ballasted solutions that we've been talking about. We're seeing a big interest and intake for those. AEE, we're turning several designs per week out for prosecution, which is great. So these are very quick to design. We can turn around the design typically the same day if we have all the information, and installation time is greatly speeded. So fewer materials are needed for a ballasted system than for a rail-based system. Typically, we can do away with the rails entirely. A lot of penetrations go away. It minimizes or eliminates completely the need for penetrations, and so that avoids a lot of the roof issues that could occur on a PV array. So no resealing of the roof, easier servicing if there's any issues, and we do see less roof warranty issues and more roofers liking this idea rather than putting penetrations in. So some of the limitations, though, for ballasted systems, so we definitely want to make and take into account any seismic-related building codes. They may mandate penetrations in any sense, so we'll talk about some strategies about that a little bit later. They're typically not suitable for roofs with greater than 5-degree slope. Roofs over 50 feet high tend to get higher wind load calculations, thus preventing the use there, so the weight becomes too much of an issue. And then wind exposure drives your ballast and module tilt limitations. We have seen a trend sometimes where some online tools that are not being reviewed, that the designer or the supplier, that we want to make sure they use the correct wind loads, exposure categories, and risk factors when designing these systems. We don't want them to be a hazard to anybody, either damaging the system or anybody underneath with wind issues coming up. So please be careful on there. All of our designs are reviewed by AeroContact, so we have in-house engineers working on the design layouts initially, consulting with you, customers, getting the correct information, vetting the designs, but all these are looked over by AeroContact and their staff. PE wet stamps, if that's required, they have an even higher level of scrutiny if that's required, and those are available in all 50 states. We'll talk about that a little bit later as well. Some contrasting points between penetrating racking and ballasting racking. So penetrated racking, as we talked about, roof penetrations will anchor the array. With a ballasted racking system, the weight of the array plus key additional ballast points will anchor the PV array to the roof. In a penetrating racking system, roof penetrations, they have to be properly sealed for the array life. We recommend that you contact a qualified roofer, or the roofer of record would be even better, to come and make sure that those penetrations are sealed properly. With the ballasted racking, we can eliminate nearly all the roof penetrations. With a penetrating racking, if we do have a small array and we are trying to get the max amount of production from each module, we could get higher tilt angles. That is possible. We'll calculate the number of penetrations needed to anchor that array properly, but you could get a 35 or 40-degree tilt angle with a penetrating racking system if needed. Ballasted racking, we typically like to see the tilt angles either at 5 or 10 degrees, and that will minimize the wind effects and minimize the ballasting and the dead load requirements on the roof. Penetrating racking, we can install that on most all roof surfaces, both flat and pitched, whereas ballasted racking, as we mentioned, the pitch of the roof limits whether we can do that racking system. 5 degrees or less is typical. With a penetrating racking system, you can achieve a lower array weight than a ballasted system, resulting in less roof dead load. Ballasted racking, there are some strategies to reduce the weight put on there, using a lower tilt, or the east-west racking would be 2 of those there, or putting penetrations in key spots, but overall we do see some higher roof loading due to the ballast rate, and therefore a higher roof dead load is added. With penetrating racking, this is where the ballast racking really shines. Any roof maintenance would require a team to go up and remove most of the array, the racking. The penetrations would have to likely be serviced, maybe reinstalled, if the roof ever needed to be serviced. With a ballasted racking, the array can be easily removed and stored, and then reinstalled quickly once the maintenance has been completed. So for a hybrid system, hybrid ballasted systems, we can basically minimally attach the systems and can offer the best of both worlds typically. So the majority of the array is installed using the ballasted system. Roof anchor and penetration points are then made in key areas which add hold down strength and lower the overall weight on the roof. Fewer penetrations would be needed to install and flash, yet most of the array is still easily removable for servicing if needed. Lower ballasting requirements also can allow the system to be installed where perhaps high roof loading is a concern. So a ballast solution could be proposed even if there are dead load requirements. And also, if the penetrations are correctly located, that would prevent the sliding of the array on the roof, any potential for sliding the array, and then static friction values could be used instead of dynamic friction values, and it increases the value of each ballasting there, and then further reduces ballasting requirements. So if the arrays can be kept rectangular, 4 penetration points at the corners would prevent the array from moving, and then we can switch to the static friction values. So each of the ballasting blocks could be are more effective. There is always an optimized trade-off between penetrations and ballasts, and often the combination of penetrations and ballasts can be the best way to meet wind and seismic load requirements. So California, other seismic areas, they will always require penetrations. So that is kind of hard to avoid in those areas. AeroCompact. So we have partnered with AeroCompact. It's been very successful. Again, we're designing several systems a week. They're currently in their 2.1 generation of racking. So their south-facing racking is available in 5, 10, and 15 degree increments. And they have the east-west available as well, and that is the 10 degree east-west. So the east-west does, as we mentioned, maximize module density. It lowers your ballasting requirements immensely. So since there's nowhere for the wind really to get up under the array, very little ballast is required on the interior of the array, and most of the ballast would be concentrated around the outside. We have an example of that later on showing that. 25-year warranty, it's wind tunnel tested, 150 miles an hour, UL 2703 compliant, so very few grounding points are needed for the array. It's all linked. It's not one grounding point, but greatly reduced. The design software, we have control over that, so we can design the systems, turn them around very quickly. So we can get a full layout, ballasting plan, material list, vet that with the customers, get systems proposed and in the hands of the end customers for approval, make changes if needed very quickly. We mentioned wet stamp engineering, if needed, is supported in all 50 states. We can get final engineering quotes. And if you guys are interested, the light version is available that the installers could use for your initial layout and planning. So it's a short training curve, but a very valuable tool if you guys are interested. Make a comment to Hannah in the chat box with your email address, and we will send you information on getting the light tool signed up. So the system there does sit directly on the roof, those feet, so front, back, and rear feet for the south degree, for example. There's a rubber EDM pad already attached to the foot, and ballast trays are added where needed that can contain the rock. Seismic would require ballast trays regardless, but in a lot of cases where seismic is not required and there's not a lot of ballasting required, the blocks can be placed directly on the feet for a few number of blocks, and further protection pads are placed under the blocks to protect the roof. It offers fast installation time with a signal tool, support for penetrations to lower the ballasting requirements or when needed for seismic. And AeroCompact shipped more than 100 megawatts in the United States alone in 2016. So here's a brief example of what we can do with the lower tilts. So with the AeroCompact 15 degrees south, so this is a building in Sacramento that I use as an example. So area code 95843 for anybody who wants to follow along there. It does have some, it is not a exposure category C, so those would raise the ballasting requirements over what I'm going to be talking about. But anyway, the building measured about 160 by 300 square feet, 300 feet, and with the 15 degrees south, I was able to fit about 1,250 modules. So if you use 280 watt modules, that's 348, a little shy of 350 kW on the roof. And over the course of the first year, that would produce 569 megawatt hours. So if we were to lower the tilt to 5 degrees, lowering the row shading in between there, I was able to fit almost an additional 200 modules on there. And that's a 400 kW array, which would produce 620 megawatt hours. So that's a 15% increase in DC array and a 9% increase in kilowatt hour output. And as we'll see later, that also benefits the cost and the ballasting and the installation time as well. Furthermore, if we did the east-west 10 degree, we could get an additional 150 modules on the roof. So that's almost a 450 kW array, producing 673 megawatt hours, and that's an 18% kilowatt hour increase over the 15 degree south option. So with this example, the 15 degree south with the 1,244 modules, that needed 3,270 ballast blocks and resulted in an increased dead load of 3.2 PSF on the roof. If we drop the tilt to 5 degrees, for a slight sacrifice in actual module production, more modules needed much less ballasting. So this resulted in a 2.8 PSF roof dead load, and it only needed 2,390 ballast blocks, 89 actually. The east-west, as we mentioned, with the ballasting located only on around the outside and very few blocks needed on the inside. So here we had 1,586 modules, and that lowered the dead load to 2.35 PSF and only required 910 ballast blocks in this example. Note that the racking costs per watt could be half using the east-west ballast racking than the 15 degree tilt racking. There are white papers out there where even if the roof is off of 180 degrees, some of the modules, if they end up resulting facing slightly northeast or slightly northwest in a ballast racking, you won't ever have a building exactly south, but that's tolerated and still produces a good amount. So the modules facing south would compensate a little bit for the ones facing slightly off of north there. Proud to announce here our partnership with Compact is allowing us to also offer their new metal roof racking solutions. So they have a trapezoidal roof system and a standing seam clamp system. So the TS system has a very short support rail, and this is attached directly to the metal on the trapezoidal roof, the top of it, sealed with a butyl tape and special grommeted screws. We do have to make sure on the intake form we correctly identify the thickness of that roof surface. It's not suitable for very thin metal roofs as we're not hitting structure. It is attached directly to the metal roof. But as a result, very few part counts, very low shipping costs, quick and economical, easy to install, and it is a fully grounded system per UL 2703. Likewise, the new standing seam clamp system as well does attach directly to the roof as standard standing seam clamp system would, but the clamp itself is wider, providing a short rail the module then sits on. And then your top-down clamp would then come in, your end clamps to your mid clamps, securing the modules to that short rail. Again, it's fully grounded, UL 2703, and technically there's two components. There's a clamp and a short rail. One tool would suffice for the standing seam clamp system. You would need a driver tool for the screws on the TS system. But we're same as the regular ballasted Aero Compact. We have the design tool. We can turn around these designs very quickly and can provide you with the intake form with the questions that we need answered. Ground mount arrays. One thing I forgot to mention was NEC 2014 and NEC 2017 Rapid Shutdown Code. They apply to systems placed on the roof. So ground mount arrays, we have more inverter options for more traditional string inverters for ground mount arrays. Forgot to mention that, I apologize. In any event, we still see a big interest in using our Snap & Rack Series 200 ground mount system for medium-sized arrays. Usually upwards about 150 kW DC is about the breaking point where the cost advantages definitely shift to other options. But upwards of 150 kW, we've had people do it up to 200 kW systems. Since it's a well understood system, well documented, And we have the design tools to turn around those racking solutions as well. We can definitely support you on those. So a typical example would be a rack of 100 280-watt modules, 25 rows in a 4-high landscape. It is most economical in the 4-high landscape situation. You'd get about 228 kW of DC on the array, and one Fronius SIMO or TriPower, 28 kW. One Fronius SIMO or SMA TriPower inverter could service that rack very conveniently, or we could use 3 of the Pro Harvest 8 kW true string inverters there as well. This rack of 100 modules, depending upon where it's installed, but it could be installed with as few as 10 3-foot deep by 12-inch diameter piers in the front, and the 4 feet deep piers in the back. That's suitable for many locations with a modest tilt angle of like 15 degrees. For those racks, you can get over 112 kW DC power on there, which would be a 96 kW array field. Easily we could get to 100 kW with a slightly higher wattage module, and we could get that array to fit in a 100-foot by 150-foot space. Rough costs, that's changed a little bit. Still about, I think, about 16 cents a watt, up to 18 cents a watt. Plus, you would also have to factor in the cost of the galvanized piping and the concrete required there. So pile-driven systems, we'll talk a little bit later about Schletter FS. They are an advantage for larger systems, but they do require special engineering studies to validate the pull-out strength of the piles and to figure out how far they have to put in. Not suitable for some ground situations or with rocks. So the snap rack could still be a viable option there. So we mentioned the optimal solution would be a 4-high landscape orientation. Of note, we are supplying rails for 3-high landscape. If you want a slightly higher tilt, but don't want the array sticking up as high, we can do a 3-high landscape. That's also available, but that would require more piers and more piping, so higher overall cost per watt there. We can get pretty high module array field densities with this system. It is UL 2703 listed, only one grounding point per subarray is required. We do have a snap rack configuration tool that would determine the bill of materials and engineering requirements. And one thing that's of note here is that we can have residential installers easily take on a larger project using a known system, as specialized equipment is not required for installation. Bobcat with an auger could punch the holes, get the trench dug, get the concrete truck in there, pour the piers, set the posts, using locally sourced Schedule 40-inch-and-a-half galvanized pipe. Since you guys source the pipe locally and we don't ship that, that does lower the overall shipping cost for the system, rather than one that would require shipping the vertical supports. Had some good success with a ballasted ground mounting system. So AeroCompact also offers their AeroCompact G and G Plus ballasted systems. So this is very similar to the commercial roof system with slightly longer legs. So it sits a little higher off the ground. Very quick install times. There's no need to dig any footings at all. No piles, no concrete, no large machinery needed. Typically, it can ship on one pallet. We see very few systems require the use of ballast trays in these, so that further lowers the overall shipping costs. Up to 1 megawatt of racking can typically ship to a job site with a single truck roll. So it's ideal also for areas that have soil issues. If you have landfills or brownfields, any areas with rocks or other obstructions or places where you can't excavate, or also for sensitive ecological areas, we're seeing some places where you have to have a mitigation study at the end of the life of the array to say how you're going to put the area back the way you found it, so that's easily met with a ballasted racking system. An optional fleece mesh could be purchased from AeroCompact to be placed under the array, and that would prevent vegetation growth around the module field. They have offered the 15, 20, and 25 degree tilt options, but currently the 20 degree tilt is the one that is stocked in the United States and can ship direct. The 15-degree tilt, we've had a little bit of issues getting that shipped in from Europe, so there's not really a reason why the 20-degree tilt shouldn't be at least considered as a first option. Or the 10-degree east-west tilt balanced option could also be employed. New this year is the Schletter FS series commercial racking. This is a pile-driven system. So Schletter is allowing us to represent them and sell and configure projects for them. So we have an intake form for this and their carport options we'll talk about in a minute or two. This can accommodate uneven terrain. A 2-high portrait design will maximize the number of 72 or 60 cell panels per post. The posts are typically pile driven, but you can do a ground screw or a cement pier if needed. It's designed for value and cost-driven projects. Do note that if you don't do the concrete piers, that soil sampling is typically required as part of the project planning process, so this may eliminate the use of this for smaller arrays, unless you're willing to pour the concrete and dig the holes. It's all aluminum extrusions, integrated grounding components, and the components are pre-assembled, allowing quick installation. Again, it is listed as UL 2703 to lower install and component count. Schletter also offers car canopy racking solutions. So there's several carport options available, as you can see in the diagram there and the examples. Small and large systems, so we could do residential carport for maybe areas where the roof surface is not suitable and they don't have space for a ground mount. We can suggest a carport. Options for cast-in-place concrete, for concrete pillars, or for micropile foundations. Single and double row vehicle arrangements. It's very flexible with the designs that we can do. Either we can do a south tilt orientation or an east-west orientation up to 20-degree tilt. Purlins can accommodate spans of 30 feet, so depending upon the wind requirements there, that will dictate the spacing of the supports. Compatible with most module types, and it is constructed of corrosion-resistant aluminum. Briefly, let's talk about inverter locations on ground mounts. So these inverters typically have very good enclosure ratings, so NEMA 4 enclosures are typical, and they allow the inverters to be mounted outside on the backs of the racks potentially for large fields. Most 480-volt three-phase inverters, they do allow for 1,000-volt wiring, and locating the inverters close to the point of connection could allow typical DC wiring to be brought to the inverters and then a short run to the point of connection. Banking the inverters also would allow easier monitoring. Many of these inverters are daisy chained from 1 to 2, 2 to 3, 3 to 4 to a master. For example, the Fronius, their Data Manager 2.0 card can support multiple inverters. So banking several inverters in a bay with a PV combining subpanel, perhaps servicing 6 inverters, would make one combined AC home run out of that very easily to achieve, and also make monitoring for those 6 inverters very capable. So 6 Fronius Simo 24s could be 150 kW to 170 kW array field. Okay, so now getting into the weeds a little bit here. It is definitely a benefit if you're considering offering commercial solar to customers to get up front and talk about the tax credits that are available whilst they are still there. So the federal tax credit was extended through 2019 at the 30% level, and then it will begin to drop to 26% in 2020, 22% in 2021. And then for commercial projects, it's going to be at 10% from 22 so far. We don't know how that will change in the future, but that's just the way it's written currently. We do see a lot of residential installers that are trying to get into commercial, not really fully understand and offer, or at least suggest, that commercial systems could apply for and get the macros depreciation as part of their cost analysis. So if they're not upfront and offering that and suggesting that, then they're at a disadvantage to a company that is. So there is language in the tax code that you can depreciate the solar assets on a 5-year accelerated schedule, and that additional tax savings could represent 10% or more of the system cost over that 5-year period. So that is a huge benefit there. Get a tax attorney, get the customer's tax advisor involved early to help calculate those options and review that with your customer. So here is some calculations that I was able to do. So IRS Form 4562 is used in calculating the macros depreciation for the total 6-year period. 85% of the net PV system costs are eligible to be depreciated, and that depreciation schedule from year 1 to year 6 goes 20%, then 32%, then 19.2%. I don't know how they came up with these numbers, but 11.52, 11.52, and 5.76%. So this amount would determine the deduction that you can claim on your taxes, and the actual value of the tax credit would depend upon their corporate tax rate. So, for example, if we did a 40 kW system, and these numbers might be a little bit dated, so $100,000 total system cost, 30% corporate tax rate. So year 1 on that $100,000, that customer can deduct 30% of that cost, or $30,000 under the ITC. And then once you start calculating the macros depreciation, on year 1 they could depreciate that asset and claim an additional $5,100 again if they're in that 30% corporate tax rate. If lower tax rates, if they're that would change that number. Year 2, since the 32% of that system cost, that remaining system cost, over $8,000, they could claim a tax credit for. Year 3 would be almost $5,000. Year 4 would be almost $3,000. 5 almost $3,000, and then expiring at year 6 for $147. So the net PV system cost over a 6-year period after your ITC credit and macros depreciation is figured out there. So if you're not offering the macros depreciation, then that customer would not be able to see that $24,000 in additional tax credits and incentives over that 6-year period. So the total incentives from the ITC and the macros total over $45,000. So the system costs in this case here would drop to under $1.15 a watt. So almost 50% of the project cost could be offset by tax credits. And this is all independent of the value of the energy provided to the customer. So this is all independent upon payback based upon their kilowatt hour rates or their demand rates or their any avoided peak demand charges. That's all benefits to the customers that you have to take into account. Again, please, get a tax advisor if you're doing commercial projects, and definitely push that value to the customer and include that in your presentations. Hannah, that concludes my portion here. I do have some photographs afterwards, but I think it's a good time to take questions.